Hi everyone, this is Darshan Senthil and welcome back to another video on differential calculus. So in our previous video, we talked about logarithmic differentiation. All right, we looked over some of the concepts and ideas behind how we use it and why we use it. So in this video, we're just going to be doing some practice problems to really help solidify the concept and really just give you some extra practice into what it really is. Because this is the type of problem that just takes, there's not a whole lot of conceptual background to this kind of a thing. It's more like a cheat code, to be honest, but it takes a good deal of practice to really understand what's going on. So I hope you find this video helpful, and yeah, let's just go ahead and get started. So first example, y equals 2x to the 2x. So first thing you need to understand is why we can't use any of our rules directly and why logarithmic differentiation is the best way to go here. So what are the two most the two things that we'd be most tempted to use here? Well, number one is the exponential rule, right? Exponential rule of differentiation, right? Because you've got something to the x power. That's really tempting to use. Another one would be the power rule. Again, because we've got some power, right? So here's the problem. The exponential rule does not work because you've got a variable there, right? Because you've got x to the x. It doesn't quite work when the exponential rule only works when you have a constant in there. So that guy's out. The power rule also does not work because you're raising it to, you're not raising it to a constant power. Now, if this x wasn't there, then yes, power rule is a go. But because it's raised to the 2x power and not just to the second power, the power rule also does not work. So therefore, your best way to go is logarithmic differentiation. All right. So let's start by just going ahead and listing our steps out for logarithmic differentiation. So our first step is to take the ln of both sides, right? We take the natural log of both sides of the equation. So let's go ahead and do that out now. So this would be ln of y equals ln of 2x to the 2x power. Pretty simple. Now number two, we're going to simplify this. Simplify, or in other words, we're just going to break it down. Because remember, the underlying idea behind logarithmic differentiation is that you use your properties of logs to decompose these sort of very complicated expressions into smaller pieces that you can easily differentiate. So we're going to do this obviously using our properties of logs. And yeah, so let's take a look at and see what we can do with this. So right off the bat, I see an exponent over there, that 2x. So I know straight away that I can go ahead and bring that to the front of my logarithm. All right, so that's what I'm going to do right up front. Another thing you could really actually do is you could split this up into an ln of 2 plus an ln of x. So I'm just not going to do that this particular time because it doesn't really simplify things as much for you. But know that you can do that. All right, you could split this up into ln of 2 plus ln of x. So if that helps you, then go for it. You're going to get the same answer. But I'm not going to do that in this particular. I'm not going to do that this time. All right, so simplify. So bringing that exponent down, that's the big step to this problem. Bring this exponent down. So you're going to have a 2x up front times the natural log of 2x. All right. So that's most of the simplifying done, and now we just go on to our third step, that is to differentiate. Okay. So let's go ahead and take the derivative. So if we take the derivative of both sides, we're gonna land up on the right side. We're gonna land up with 1 over y dy dx. And again, I cannot stress this enough. Do not forget that 1 over y. All right? Don't forget that 1 over y. Because it's really easy, right? It's really easy to miss that while you're doing whatever you're doing on this side. But that thing can still really contribute a great deal to your final answer. So don't forget that 1 over y over there, okay? And all of this is going to equal 2x, or sorry, that'll be the derivative of all this. So we're going to have a product rule down here. So it will be equal to the derivative of that whole thing over there. So you'd have a 2x ln of 2x. So you'd have a product rule over there. So let's break that down. So this would be the derivative of that, which is 2, times ln of 2x plus the derivative of ln of 2x, which is going to be 1 over 2x times 2 times the 2x. All right, so let's put everything together. That's going to give us 2 ln of 2x, and this 2 and that 2 are just going to cancel, and that x and that x are actually also going to cancel, so you're just left with plus 2. All right, and that is all going to equal 1 over y dy dx. Right, and for your final step, all you basically have to do is multiply the y to both sides, and your final answer should therefore be 2y ln of 2x plus 2y equals dy dx. So that right there would be your final answer. And I just went ahead and distributed the y to each of these terms. So that would be your final answer over there. Now again, you could be tedious about this. You could be very rigorous about this. And you could go ahead and plug in for y. You could go ahead and plug in that expression right there. You could plug in that for y over here. And you would be perfectly correct. It is good practice to go ahead and plug this function back in here. I'm just not going to for these examples. In this example, again, we're just going to have to use our logarithmic differentiation, because as you can see, we've got a product rule and a chain rule, a whole bunch of things there that we don't want to have to do. So let's go ahead and break this down. So ln of y equals ln of square root of 3x squared plus 3 times 3x to the 4th plus 1 cubed. Okey-doke. And now let's go ahead and do a couple of splitting up, a little bit of splitting up. So obviously this is going to be one big thing we can split up. I see a couple of exponents over there, and again, keep in mind the square root is really a 1/2 exponent, and something raised to the 1/2. So there's a lot of things we can do. So anyway, let's go ahead and take this piece by piece. So number one, we'd have ln of 3x squared plus 3, and then we've got the 1/2 power down up there, so we could go ahead and bring that down here. All right, plus, because we're adding our logarithms, we have the ln of 3x to the 4th plus 1, and we've got that 3 down here. Okay, so important question now, can you break this part up here? Can you break this guy up over here? Can you break that up? The answer is no. Okay, you cannot break that up any further. That's because it is a sum, right? It's a sum, not a product. You can split up a product. This you cannot, because it's a sum. So you cannot touch this any further. So you're just going to have to use a chain rule there. So don't try to split that up. You're going to get a wrong answer. All right. So now we've done all our simplifications. Let's go ahead and differentiate. So again, we've got 1 over y times dy dx. So that's going to equal, keep our 1/2 out here, times 1 over 3x squared plus 3 times the derivative of the inside by our chain rule. So you'd have a 6x over there, right? Plus, again, we've got a 3 out here. So this would be times 1 over 3x to the 4th plus 1 times the derivative of the inner function again, which is, again, you'd have to use the chain rule. So the derivative of that would be times 12x to the 3rd. All right. So that's basically what we've got here. And now we can just go ahead and put these things together, and so that would leave us with 1 over y. Actually, I don't even need that. So this is all going to equal. So the 2 and the 6 would cancel. You'd be left with a 3 there. So you'd have 3x over 3x squared plus 3 plus, so nothing really cancels here, but 3 times 12 is going to give you 36. So you'd have 36x cubed over 3x to the 4th plus 1. Okay, and over here you can actually factor 3 out of the denominator, so this would actually be 3x squared this would actually be 3 times x squared plus 1. So that 3 and that 3 would cancel. So ultimately you'd be left with... So you'd eventually be left with x over x plus 1 plus 36x cubed over 3x fourth plus 1. Okay, and now finally we just go ahead and multiply the y to the other side, which would give us that dy dx equals y, I'm just going to leave it on the outside, x over x plus 1 times 36x cubed all over 3x to the 4th plus 1. Sorry, it's not very neat, but you get the picture. So that right there would be your final answer. Y times x over x plus 1 times 36x cubed over 3x to the 4th plus 1. So that would be your final answer right there. And again, you could plug in that expression in for y. I'm just choosing not to. All right, so let's move on. So this is the last example we'll be doing in this video. And again, same idea. So you've got a chain rule, a product rule, and a whole, and I really hate doing chain rules with square roots in them just because you get negative exponents. So it's just much easier to use logarithmic differentiation here. So let's go ahead and do that. And also don't forget, you've got another x to the x here, so you will need logarithmic differentiation whether you like it or not. So ln of y again is going to equal ln of e to the x squared times square root of x to the square root of x power. This would be a real pain to differentiate without logarithmic differentiation. Alright, so this is the last example we're going to do today. So again, we do need logarithmic differentiation for this problem because you've got an x to the x, and also because you've got that nasty product rule there, and logarithmic differentiation is the way to go. So again, the first step is the same as always, just take the natural log of both sides, is ln of e to the x squared root x to the x. Alright, and now let's just go ahead and see what we can simplify. So again, I see a product over there, so I'm going to split that up into a sum of logs, and then of course we've got our exponents up there, so I'm going to bring those down as well. Alright, so this is going to equal, you've got an x squared times ln of e plus you got a square root of x, so you have root x ln of root x. And if you notice, I can actually do another simplification right off the bat here, because again, a square root is very simply something raised to the 1/2 power. So I can go ahead and take that 1/2 and I can bring it right up to the front over there. What I'd really have here is I have x squared. So the ln of e is just going to cancel out. So that's going to be just 1. So I'm just going to be left with a 1 over there, which works out really nice, plus the square root of x, and that's really a root x over 2, right? Because I'm bringing that 1/2 power out, and all this times ln of x. Cool. So that's basically how we'd set this up. And now we just take our derivative. So this would be 1 over y dy dx. And now we'd have a 2x there, plus the derivative of root x is 1/2. If you're just using power rule, that would be 1/2 x to the negative 1/2, or 1 over 2 root x. So we'd have, but we'd really have a product rule here. So this would be, we'd have 1 over 2 root x times ln of x, plus, or actually that would be 1 over, that'd be 1 over 4 root ln of x, right? That would be 1 over 4 root ln of x. And the reason for that, if you take a look here, is you've got a 2 over there. It's over 1/2. So you've got a 1/2 coming from here, but you've also got a 1/2 coming from here. So it's really a 1 over 4 square root of x, right? Times ln of x. This and plus this would just be root x over 2x. Again, because the derivative of ln of x is 1 over x, so I'm just putting that x in the denominator and leaving this as it is. All right. So you could simplify that further, but you don't really need to, because you'd get a negative exponent, and yeah, you don't need to. All right. And then for the final step, you just go ahead and multiply by y to both sides. So you multiply by y, multiply by y. So you're finally left with that dy dx equals 2x. Don't forget to tag on the y over here as well, not just to this thing over here, plus y 1 over 4 root x ln of x plus square root of x over 2x. And that is your final answer. And for the last time, you could plug in that expression over here, and I think your teachers could tell you whether you should do that or not. But again, the reason I'm not doing it is because A, I don't have space on the slides, and B, because the real picture I want you to get from this is all of this over here, right? So what we're doing here is the real picture I want you to get. So how are we using the properties of logs to split this up? How are we using that to really make this into something that's easy to differentiate? That is really what I want you to learn from this, right? And that concludes this video. So thank you so much for watching. Please don't forget to like, share, leave a helpful comment. I am always looking to improve these videos. And please do subscribe. And yeah, check out some more videos. And I hope you found this helpful. Thank you so much for watching.